Imagine you're in a world where the only source of power is chemical reactions. How would you turn that into electricity for your gadgets and gizmos? This isn't some far-off fantasy realm, it's the real-life science of electrochemistry. Electrochemistry, an intriguing domain of chemistry, explores the relationship between electricity and chemical reactions. Dive deep into this fascinating world and you'll find two main characters: redox reactions and electrochemical cells. Redox reactions, or reduction-oxidation reactions, are a dance of electrons. In this dance, there's a transfer of electrons from one substance to another. The substance that loses electrons is undergoing oxidation, while the one that gains electrons is experiencing reduction. Remember it with a simple mnemonic: oil rig. Oxidation is loss, reduction is gain. Now think about a party where this electron dance happens. That's an electrochemical cell. It's a system where a redox reaction splits into two half reactions. One half is the anode, the site of oxidation. The other half is the cathode, the place for reduction. So how does an electrochemical cell work? Picture it as a stage where the electron dance happens. At the anode, a substance gives up electrons, becoming positively charged ions. These ions move towards the cathode, pulled by an invisible force. This movement of ions creates an electric current. But wait, what's driving this current? It's the potential difference or voltage between the anode and cathode. This is the electromotive force, EMF, the driving force of the cell. The greater the difference in the potential, the more powerful the cell. You may ask, how can we measure this EMF? Enter the Nernst equation. This equation calculates the EMF of a cell at any temperature and concentration. It's like a GPS for navigating the world of electrochemistry. Electrochemistry isn't just a fascinating science, it's also a practical one. It powers batteries, fuels cars, protects metals from corrosion, and even helps in the extraction of metals. In conclusion, electrochemistry is the science of harnessing the power of chemical reactions to generate electricity. It revolves around redox reactions, where electrons are transferred from one substance to another. Electrochemical cells are the stages where these reactions occur, with the anode as the site of oxidation and the cathode as the site of reduction. The driving force of these cells is the EMF, which we can calculate using the Nernst equation. So, the next time you switch on a gadget, spare a thought for the incredible science that's powering it: electrochemistry. Isn't it electrifying?